Hello dear students, welcome back to physics online class. Look at the 10th question. A bar magnet of magnetic moment M is cut into identical piece along the length. So magnet is there, its magnetic moment is M. So I will cut that magnet identical pieces. Look at here. One piece is bent in the form of semicircle. So one piece is bent in the form of semicircle if two pieces are perpendicular to each other. Look at here. The arrangement I will take in this manner. This is semicircle, right? And this is remaining part. So total magnetic moment is M bent into two identical parts. So it becomes as M by 2. So these two are perpendicular, right? Now, which thing they asked determine here? Then resultant magnetic moment is. So I want to find out that resultant magnetic moment. So I hope you remember, if that magnet is bent in a semicircle form. So what is the connecting formula? M dash, which is equal to 2m sin theta by 2 divided by theta we can consider. So if it is semicircle means we got that answer. Look at here. M dash, which is equal to 2m. Here magnetic moment is m by 2. So sine of theta by 2. So sine of theta by 2 means sine of 180 by 2, 90 here. Sine of 180 by 2 divided by theta. Theta means pi. Look at here. M dash, which is equal to, this will get cancelled here, m by pi. What is the answer I get it here? M by pi here. And remaining bar magnet having that magnetic moment m by 2. So this will becomes m by pi and this becomes m by 2. Then what about the resultant magnetic moment m double dash, which is equal to square root of m by pi whole square, m square divided by pi square, plus of second one is m square by 4. Look at here, or it is in the form. So in that option they mention like so, m by pi whole square plus of m by 2 whole square. So this is the required answer for 10th question here. Now we'll look at that next question. 11th question we will solve. Look at that 11th question. An isolated unit north pole experiences a force of 2 into 10 to the power of minus 7 Newton. Look at here, how much force it is experiencing? 2 into 10 to the power of minus 7 here. North pole, unit north pole they mention. So look at here, pole strength I will take it as 1 ampere meter here, right? When kept at a distance of 1 meter, distance which is equal to 1 meter, 1 meter from a magnetic pole in air, pole strength of the pole is. So m2 value I need to find out here. What is the connecting formula? F, which is equal to mu naught by 4 pi m1 into m2 divided by d square here. Force value is 2 into 10 to the power of minus 7. What is the value of mu naught by 4 pi? From that moving charges and magnetism we know that this is equal to 10 to the power of minus 7. m1 which is equal to 1, m2 I need to find out here. D square means distance, so that is 1 square. Look at here, sorry, m2, this term will get cancelled out, so that m2 value is 2. So what is our required answer? 2 ampere meter. Okay. Look at that 12th question here. Two magnetic poles, one of which is 4 times as strong as the other. It means that one magnet is there, its pole strength is m, second one having that 4 times of that first one, right? Other exert a force of 64 milligram weight. Look at here, m which is equal to 64 milligram weight here, right? Milli means 10 to the power of minus 3. Gram, how to convert into kg? 10 to the power of minus 3. So 64 milligram weight, I can rewrite it as 64 into 10 to the power of minus 6 kg weight. Milligram weight into kg weight. I written like this. When placed at a distance of 10 centimeter apart, 10 into 10 to the power of minus 2 or 10 to the power of minus 1 meter, right? Then strength of the poles are, I want to find out that m1 and m2 value, the simpler thing. Again I will use that same formula, mu naught by 4 pi m1 into m2 divided by d square or r square. Force which is equal to m into a, I can write it as m into a or m into g here. I will write it here only, m into g. I will substitute the value here. Mass is how much? 64 into 10 to the power of minus 6. G value is 9.8 r, which is nearly equal to 10. Mu naught by 4 pi value 10 to the power of minus 7. M1 is m, m2 is 4m, divide by distance is 10 to the power of minus 1 whole square here. Distance is 10 to the power of minus 1 whole square. Look at here, 64 into 10 to the power of minus 5, here minus 2, so that is minus 7. This is 10 to the power of minus 5, this is 10 to the power of minus 2. Bases are same, powers are added here. Divide by 10 to the power of minus 7, 4. So this is equal to m square. Look at here, m square which is equal to 16, m which is equal to 4 here, 4 ampere meter. So m1 is 4, m2 which is equal to 4 times of m, 4 into 4, 16 ampere meter. This is the required answer. Look at here, question number 13. Let us solve that 13th question. Two poles of same strength attract each other with a force of magnitude F. So two poles are there, it will get attract with a force of F, I can say, when placed at the two corners of an equilateral triangle. Look at here, when it is placed at the two corners of an equilateral triangle. Equilateral triangle means like this, I can take it, right? When placed at the two corners of equilateral triangle, if a north pole of same strength is placed at third vertex, if it is at third vertex, it experiences a force of magnitude which is equal to, what is the force at this point? I need to find out here. Look at here, for north pole outward, for south pole inward direction, this will be the resultant force and angle will be 120 degree. Then resultant force which is equal to, right, F1 square means F square plus 2 times of F square. What is the angle here? 120 minus of 1 by 2 F of r, which is equal to 2F square minus of F square. So F of r which is equal to square root of F square, or which is equal to F. So this is the value of resultant force which is equal to F only, right? Next we will solve that question number 14th. Look at here, question number 14th here, right? Force between two identical bar magnet whose centers are r meter apart. Look at here, initial distance is r here and force between them is 4.8 Newton here. Then axes are in the same line, means along the axial line, axes are in the same line. If that separation is increased to 2r, then what about the force I need to find out here? Along the axial line means, shall I take this is the connecting formula, mu naught by 4 pi 2m into r divided by r square minus of l square whole square I can consider here, right? I can take, if it is negligible length, r to the power of 4, I can take force and field are directly proportional here, right? Then I can take it here F1 by F2. So this is B is inversely proportional to R to the power of 4. Then similarly F1 by F2, which is equal to R2 by R1 whole to the power of 4. Why? Because magnetic field is inversely proportional to fourth power of the distance, and force and magnetic fields are directly proportional. So I'll made that equation like this. F1 by F2, which is equal to R2 means 2R, R1 means R whole to the power of 4. F1 is 4.8, F2 is yet to be determined, 2 to the power of 4. So what's the answer? So that is 16 here. F2, which is equal to 4.8 divided by 16, that is 0.3 Newton. So this is the required answer for that 14th question. Now look at that 15th one. 2 points A and B are located at a distance of 20 cm and 30 cm from the center of a short bar magnet on its axial line. So for short bar magnet, what is the connecting formula here? Mu naught by 4 pi 2m by r cube. So hope you remember this formula. Then ratio of their magnetic induction at A and B, B1 by B2. So magnetic induction is inversely proportional to cube of its distance here, R2 by R1 whole cube, B1 by B2. R2 value is how much? 30, R1 value is 20 cube, B1 by B2, which is equal to 3 cube means 27, 2 cube means 8 here. So this is the